Hi, I'm Luke, and that's a tutorial for the modular procedural materials asset pack on the Unreal Engine Marketplace. I already have the project of that asset pack open here, so when you download it, you can create a new project with it or add the content to another existing project. First, let's talk about the folder structure. So when you open up the project, you have a few subfolders. Let's see what's here. So the first one is color curves. That contains color curves and the texture, a curve atlas for the gradients. So most of the gradients in the materials use that for coloring. Then we have the maps folder that contains this one map that's already open here. Then we have material functions that contains all the basic functions. So we have fractal functions here. We have the sine distance functions. So then transforms, which usually means UV transformations, and utility function. And then there is this quick blocks folder. I mentioned that last because each of those functions here is basically a copy of another function, but with, if you open it up, with all parameters that you need already added. So if you want to quickly create new materials, you can use those quick blocks and just drag it into an empty material and link them, and then you have a new material and don't need to worry about all the parameters here because that's quite time consuming to create them, name them, and so on. So that's the material function folder. The next folder is material instances. Here that are all the instances that you can see here and a few more. Then we have material layer blends that are blend functions that you can use in layer materials. So what's the next? Material layers. That's the actual layers for the layered materials. At the moment that only contains simple colors and some noise functions. Then we have parameter collections. That's only one parameter collection, and it has some global parameters like global opacity, global emissive, and so on. There are functions that read that you could add to other materials, that you have a global parameter to control it. But the most important thing here is that number of curve atlas curves. So that says 49. That means we have 49 curves in the curve atlas. So if you add more, then you also should, or you have to change that value here to the number of curves. The reason for that is that in many materials, the materials use that curve atlas in a way that you can switch gradients by gradient index, and for that, in some cases it's possible to read the size of the curve atlas, but not in all cases, and in those cases this value here is referenced, so that needs to match. Then we have the base materials here, and yeah, meshes. I only have this Unreal shader ball here for demonstration purpose. And okay, so let's get into the map and see what we have there. So the first part are the SDF function. SDF means sine distance function, and it's basically a mathematical function that tells you where the edge of an object is. So let's go to the main material. You can already see here that it has a ton of parameters. I will explain where they come from. Okay, so all those parameters, they come from this is one of those quick blocks, yeah, and it says quick UV transforms. If I go into that, there are a lot of UV transformation functions just daisy chained with a switch to turn them on and off. So if you turn them off, it's not used, nothing happens, the material doesn't need more performance, but you can simply turn them on and then you can use the effect. So all the parameters here in that other quick block would appear if you enable it. I can show that. Okay, where is that? For instance, if I go to hex tiling, which that will not fit that object here because it's probably too big and will be cut off, but if I enable that, you see that's hexagonal tiling. As I said, it's too big. Yeah, and then you can change the values here, and if you don't need it, you simply switch it off, and that's a very quick way to try out different functions here. Okay, so but back to the SDF. So here, this UV transform node we are already talking about, and then here that also adds another UV transformation, and then we have this here. That's the actual sign distance function. If let's see. Okay, so what does it do? That says SDF 2D eye. That means it's an eye shape, and what an SDF does is it tells you the distance from the edge. So if I zoom in, you can see here the edge would be 0, and the outside increases with distance. So if I have here a distance of 5 units from the edge, I would have a value of 5 here, and to the inside it's going to be negative, but in the same manner. So if that's distance of 5 to the edge, I have -5. So that gives me that, and then I have this node here which says distance coloring. So that's also a quick block. There are different functions available for working with the SDF. So you have your basic shape, but what you can do with the shape is, of course, you can draw just the shape with a border. Then you can fill it on the inside. You can also have a glow on the outside. Then you can have these ripples here on the outside and on the inside. And then we also have this wave function here that only this one here has it, but that distorts the edges with a sine wave. So let's go back to the material here. So, and those functions are all here. So that's the border, then the sine function on the outside and the inside, the fades, which gives you the glow to the outside and to the inside, and then the actual coloring, which use the curve atlas, as you can see here. And yeah, you can also switch to coloring by colors. That will just do a linear interpolation over the defined colors, but it's way easier to use the curve atlas, and I'm not quite sure, but I think it's also better for performance. Okay, and then what we also have here is a block for radial tint, so you can change the color to the outside, and opacity. So what you can do here is just set the opacity and also do a kind of chroma keying thing. Okay, and what was that? Quick color. Yeah, okay, that's just takes the particle color and a few other things into account. So the global values here, global emissive, global diffuse, and the global tint, that takes the global tint 1, 2, 3, and so on. Okay, and that's here. And then you have diffuse and emissive and opacity as an output, and that's going here to the values where it's meant to be. If you find functions on the internet for SDFs, you can easily just add them. It's just let's have a look how that looks. Where was that? SDFI. So in that case, that uses a custom shader node with the shader code added here. It's very easy to change it. You just copy that to another function and change the shader code, or you can also do that with nodes. Now here we have the fractal functions, and they all have, or most of them have a auto animation on it. I usually turn that off when I use them and animate that from, let's say, Niagara particle systems. So there are different kinds of fractals here, and which one to take as an example? Let's do that one here. That's a Julia fractal. Again, here are a lot of functions to enable, like that here, for instance. Yeah, okay, that's not that beautiful in that case, but again, you can enable all those basic UV functions here. So that's this node here. And then here we have a quick node for the Julia fractal. And that, yeah, you can see there are a lot of parameters here. And here, that's something that's very important for me. That's a dynamic parameter. When you use that material in an Niagara system, you will be able to directly change those dynamic parameters from the system. You can have 4 of those dynamic parameter nodes here. If you copy that, you will have another one, and then you need to set the index to 1, 2, and 3. Then you have all 4, but 4 is the maximum. At least I think that's the case. I have never used more. Okay, and then here are a lot of parameters already. Then we have this quick surface properties node. What that does is it uses the input value and creates color and opacity for that. So you have the gradient color from the fractal, or it colors the fractal using a gradient, and there are different ways to do that. Let me see here in that. Where is that? Yeah, here, for instance, you can select the oops, okay, I need to use one that's black. Yeah, okay, so Okay, so you can select the curve here, and somewhere here is also, yep, if you turn that off, it gives you another way of coloring. But I would always use that here. Okay, that's it for the fractals. And the next one here are the UV morphs. So, okay, I misspelled that here. It's already submitted to the marketplace, so my bad. But the T is wrong, of course. So what that does is the UV morphs take UV coordinates and morph them in a way. So what you see here is that fisheye effect, and here we have a repetition kaleidoscope thingy. Then this one is called a Mobius inversion. Here we have just a radial thing and spiral here, and this one is it's called a toroid. That's like the inside of a torus object. And then here is it's called trochet, or I cannot pronounce that. It's trochet effect or whatever. It's spelled like that. You can look it up how to say that. And this one here is simply called warp. So it's kind of kaleidoscopic effect, but with some extras added to that. So it's not equally split. So there are some smaller segments and some bigger. So it works a little bit different. And one which is usually very important, at least for me, and is not here on that wall, is the hexagonal tiling. You can see that here, so you can use that for many different things, but I will come to that later. So let's go into one of those materials. Let's just take that kaleidoscope effect. The UV morphs are used in all other materials and can usually be just turned on and off, and then when you turn it on you have the parameters for that and you can change that and so on. So yeah, and that's exactly what I did here. So here is that quick UV transform node again, which has all the UV transforms in it, and then here you can see that is the actual material that is morphed, and then I just route that to the output. Yeah, opacity isn't even used here, height map neither. So that's just to show those different materials. And how you would do it is you can look it up here. So okay, it all starts with that UV input normalized. That's very simple. It takes the texture coordinate and subtracts 0.5 and multiplies by 2. So that gives you that UV coordinate system here. And then so if you create a new material, you will use that one and then add whatever UV morph effect you want to have. So here in that quick transform block, you already have all of them daisy chained, and you can turn them on and off. So if you rearrange them into different order, you may get totally different results. And then on the output, here in that case, you also have a few additional outputs from the from the hexagonal tiling if you use that. So that has like the ID of the hex cell basically and stuff like that, or a random value, but usually you only need the output UV, which gives you a new UV coordinate for further processing. So here that is the new UV coordinate, and that's used as input for the texture, and then the texture is bent or morphed like that. Okay, and that's the important thing is the UV morph is usually always in the start of the material graph. So that's the first thing you do. Then you have your new UV coordinates, and then you add stuff like the fractals or SDFs or something like that, or texture, for instance. Okay, so then here we have some dissolve effects. I turn up the light a little bit so we can see that. So here in the first object here, the object is dissolved by a noise pattern, and here we have the hexagonal tiling. And oops, why? Okay, now I got the object. Let's go into that material. Here you can see it a little bit better. That's what that does, and it has basically two sides. The one that's here looks like metal, and then the invisible material here, and in between there is this border that has a nice glow on it, and somewhere here edge emissive. So if I turn that up to 1000, you will see it's increased, so you can use that. But let's go into the material. Okay, here that's just for animation. You might want to use that, or maybe not. Maybe you just want to have a dynamic parameter here if you use it with a polygon system, or you have, maybe you want to use it for a character, and then you just take a normal parameter here and call that from your character asset and change that from 0 to 1, where 0 is, I'm not sure, I think 0 was completely dissolved and 1 was completely opaque, but it might be the other way around. Okay. Then this here is the core node of that material. It's dissolving by a noise. You have parameters for the noise function, and if we go in there, that's the noise function, and here that's called dissolve by alpha value. That's for the control of the border, so you can have a width of the border, and then like density means lower densities, like a fade out for the border to have it. Yeah, basically that's the sharpness. That's a good word, I think. So that noise function generates values from 0 to 1, and they are put into that here. So you have the border at the threshold value, and then you have something that is 0 on one side of the border and 1 on the other side of the border. And you can input each function that produces values between 0 and 1. So you can also do that with a texture, or in the other case it's done with a hexagonal tiling. And then, yeah, in that case we just interpolate between, so we have the edge here, so that's the background, that's the color of the edge, and the rest is just 0, which is the transparent. Then we have a few other effects. So that's, I still don't know how to call that thing, but it uses a sine function to apply a gradient to the object, and that in a global coordinate system. So that means it's kind of projected onto the object, so you don't need a UV mapped object. That's what I use that for is if I have tentacles and ribbons and stuff like that, I use that material a lot because that just goes along the object and it's very easy to adjust. Then here, that's kind of a black hole thingy that bends the light with a little bit refraction. Here, that's that's basically a combination. That's a radial UV morph with this trachet pattern here, and here we have that's a simple noise. Okay, and here we have a few examples what you can do, and here we have the animated hexagonal tiling. Okay. Let's just see. Again, here are all the functions to just check and try out for prototyping. Okay, so here we have those UV transforms again, and then different SDFs with parameters, and they are added. So yeah, it's not really complicated, but a quite big network here, and here that draws the border of one, and yeah, inside of that there is the border of the second SDF. So that combines two SDF. So this one is a frame, and that's the pattern on the inside, and it combines them. Okay, then here we have layer blend functions. So here you go to layer parameters, and then you can add material layers, and in between those material layers you have the material blend functions that basically tells the layers where to start and where the next layer starts. And in that case, for instance, you have a noise function that splits two layers. What we have here is basically the dissolve effect, but made with layers. So in that case, if you have a look at that material, so that has a blue layer and a red layer, and in between there is that layer function that's called blend hexagonal tiling. So we have the blue material and the red material, and in between we have this border thingy. You see that orange glowing thing? You can set that somewhere. That's the gradient color and the emissive value here. So let's turn that up to super bright. Yeah, okay, that's it. So the highlight is defined in the blend. Maybe open up the blend to show that. So that's that blend function. It takes a bottom layer and the top layer, and then the actual blend value that's defined by some hexagon tiling function. And yeah, here that's just for animation to show it, and here that's a dynamic parameter for control with Niagara again. And then you have that highlight, that's output to the material attributes, and then we have the output of the layered material. Okay, so that's a hexagonal tiling, and here that I simply called that slice. So here one material is one layer is the gray layer, and the other one is a layer of invisible material, and you can define the width of that slice, and then you can control it. And here that's this material again, so you have one layer that gives you that star field kind thingy with, yeah, diamond shapes basically, and well, yeah, the other material is just a noise gradient, and in between you have this blue line here, which is the border in that case. But you could add any material, any layer here on each side of the material. And the great thing is you cannot only do that with two materials. You can have a layer, then a blend, then another layer, then another blend, and so on. So you can nest that quite a lot. If you want to have the content from the package as layers, you can usually simply copy a material and let me see. You would copy the material and then would copy that part from the layer and just add the outputs of the material here. So then you have a layer that you can use in layered materials. Then here we have something that I call SDF particle material. What that shows is just how to morph between different shapes. So I like to use that for particles. You can create really crazy effects with that. That doesn't use a layer. Okay, so yeah, you see there are a lot of parameters that you can use to customize only that thing without even touching the graph. But let's go into the graph here. Yeah, well, that's complicated. So these two are just for animation loops, and here we have 4 dynamic parameter nodes. If you have a look here, pattern zoom, element zoom, pattern type, gradient time, and so on. So those parameters here all help to change the shape of the either of the inside pattern or of the frame. Okay, yeah, and that's quite a complicated graph here, but you see here that's the inner pattern and that's the frame on the outside, and they are combined again. Particle color is added on top, so to tint the whole thing. And yeah, that's it basically. Okay, then we have some post effects here. The later one are post effects. The first one is cell shading post effect that works on basically all meshes as well as particle meshes, but not on sprites usually. I don't know if there are exceptions to that, but as far as I have seen, it doesn't work on sprites. What the effect does is it gives you outlines, then it splits up the color range into bands. I think here are 4 bands. I guess you can see that in the video, but that's just like that cartoon effect. Yeah? And then you have these screen space halftones, how they are called. So the small dots that you can set them to appear in darker areas, or where usually the shadow or where no light touches the object, but you can also change that to appear in everywhere or in the light areas. And the material also has some color adjustment functions where you can just set the brightness and fine-tune that, and also change the overall hue and so on. So then the next post effect is just color change. I just needed that for some stuff, so I quickly made that. Standard post effects have ways to change colors, to adjust colors, but I haven't found an inversion and hue shift, so I just added that. And then the last two are UV morphs. So if you really want to fuck up the user, then you do that and you get totally lost and don't know where you are, but you can use all the UV morphs as post effects. Okay, that's it. Thanks for watching. I hope you like the asset pack and also know how to use it now. And I will end this with a video of stuff I created with all those materials. Have a nice day. Bye.